Hey class, so I wanted to go over numbers 3 and 4, and I'm just going to go over a few examples. Okay, so for number 3, it gives you a raw score, and then it asks you for the corresponding z-score. So the equation from lecture is, I wrote it up here already, so it's your z-score equals x, which is your raw score minus the mean, all over sigma, or the standard deviation. Okay, so I wrote down for the problem, we're given the mean is 20 and the standard deviation is 3. So for a raw score of 15, to find the z-score, we just have to plug into the equation. So the z-score will equal 15, which is our raw score, minus 20, over the standard deviation, which is 3. So that would be negative 5 over 3, which is 1 point, and so it's 1.6666, right? But if you round it, it should be negative 1.67, right? Because it's 15 minus 20. So a lot of students got the rounding incorrect. It should be negative 1.67. Then I also want to do the raw score for 22. So the z-score will equal 22 minus 20. Again, I'm just using this equation, all over 3. So that will be 2 over 3, which is positive 0.67 for the z-score. And then for the next problem, for number 4, I asked about drawing out a raw score 15, right? And then how that corresponds, then how much of that, what area does that correspond to, right? So for 15, we already calculated this z-score of negative 1.67. So I'm going to just draw it out. So if you remember with our normal distribution and our z-score distribution, 0 is always the middle, and all these scores above are positive and all these scores below are negative. So negative for a raw score of 15, that is at negative 1.67, and that corresponds to a raw score of 15. And then if you color that in, anything below a raw score of 15 will be colored in correspondingly to the tail. And in order to calculate what this area under the curve is, or what the proportion of that is, you would have to use your z-score table. And you can use your z-score table because this is a mirror image, right? So you can use your z-score table, go to a z-score of 1.67, even though it's positive. You look at the area under the percent in the tail to be able to get to this area. And again, it's because you can flip it on itself. So this proportion here is exactly the same as a positive 1.67 over here. So that is the proportion. You just have to go to 1.67, look at the percent of the tail, and that will be what's under here.